Okay, we're going to go ahead and talk about some more problem solving, in particular word problems. I know many of you have shared some concern that this is a hard section and it's really difficult. Well, it's good and bad. Good in that the fact that you're struggling is not a bad thing. It means you're learning something new and you're learning how to work that part of your brain. That's definitely the good news. The bad news is we got one more section of it here in 3.3 before we take our exam. So definitely want to make sure you guys budget enough time this week to really sit down and do a lot of this homework. The only way to really get better at this is to practice. So in word problems that we're covering in section 3.3, we're going to specifically work on geometry and how that plays a role in our word problems. Geometry, of course, is just the space we live in, so it applies to everyday things, whether we know it or not. In particular, anything with a length or a volume or an area is geometry. Those of you that are maybe experienced working on houses know geometry pretty well. You know, you take lengths of board, you take areas of square footage for tile, and you take volumes for concrete. How much concrete you'll need for a job. So geometry is pretty relevant in all of our daily lives. Some of the common formulas for geometry figures or concepts come from, in particular, we're going to be looking about area and perimeter here. Area, as we know, is a two-dimensional space. It's a two-dimensional unit, and it includes the length and the width. So the area of a square, if we have the sides are S and S, of course, the definition of a square is all four sides are equal. The area of a square is just S times S, or simply S squared. The perimeter is going to be the length around. It's a one-dimensional unit. If I was to get string and tie it around here, how long would that piece of string have to be? So we know that string is just one-dimensional. It's a line, and the line around here is going to be 4S because we go 1S, 2S, 3S, 4S. So for a square, it's a little different than for a rectangle. The difference between a rectangle and a square is a square has a width where the widths are not the same distance as the lengths. So we have two different lengths, or the lengths are the same, but the widths are different. So for a rectangle, the way we find the area is length times width. And for the perimeter, we know it's 2L plus 2W. Some shapes we haven't talked about yet, really, at least in this class, are a triangle and a trapezoid. And here are some formulas for the height or the area of a triangle. And it's going to be 1/2 base, the base of your triangle, times the height of your triangle. And it's real important to notice that h goes from here perpendicular up to your end. It's not the length of this side, but the height of your triangle from your base, okay? And the trapezoid is going to be 1/2 height, and then times the quantity of a plus b. So you have to add a plus b, multiply that by your height, and take 1/2 of it. Okay, so these are just common formulas that you'll have to know. So it's a good thing to maybe keep note of these important formulas. Here's a word problem. A rectangle has a width of 10 inches and a perimeter of 125. Find the length. So we go and say L is going to be the length. There are no other unknowns, right? Because we know the width and we know the perimeter. So we can just write our equation. 2W plus 2L is equal to P. And we know this. Again, that's from our equation that we learned up here. If we substitute the width, which they gave us, which is 10, and they substitute the perimeter, what they give us is 125, then we can just solve for L, and we know how to solve for L by using all of our rules. We just isolate L, get L by itself, and we find that L is equal to 52.5 inches. Again, you can check your problem by plugging L of 52.5 into the original equation, and you should get, indeed, the perimeter is 125 inches. The circle is a little different. It deals with a number called pi, and pi is designated by this little symbol here. It's a Greek letter pi. Pi is actually a value. It's not a variable. Remember, keep in mind, pi is not a variable. It's not like x or r or p or l or w. Pi is an actual real number. It's a natural number, and you'll learn about what a natural number is later. But it's a natural number, and we estimate that value to be 3.14. Those of you that have a calculator that have pi on there, you can put in pi and hit enter, and you'll see it's 3.14 and then a whole bunch of numbers after. That means it doesn't have a nice round ending number, but we estimate it to be 3.14. So since we have a circle here, we see it doesn't have any nice sides that we can find to take the area or the perimeter. Instead, all the only dimension they give us is a radius. The radius is half the distance from the center, or is it the distance from the center of the circle to the end of the circle in any direction. The diameter is going to be 2 times the radius, so it goes from one side to the other side through the center point. That's the diameter, but a radius is just from the center to the end, and that's what we specify as r. Area is going to be pi times r squared, so this value squared times 3.14. The circumference is what we call perimeter of a circle. Okay, it's just the fancy word for perimeter, and that is just 2 pi r, where r is our variable, and we know pi is a number, 3.14. Here's a problem. Find the area and circumference of a circle with a radius of 5 inches. So the area we know is equal to pi r squared. If r is equal to 5, we know 5 squared is 25 times pi. And if we approximate that out, if we estimate pi to be 3.14, our answer is 78.54 square inches. Notice how I round here. Because we estimate pi to be 3.14, we estimated 0.14 2 places after the decimal. Our answer should end, unless otherwise noted, in 2 decimals after the 2 places after the decimal when we round off. The perimeter is equal to 2 pi r. So again, 2 times pi times r. And we can use the commutative properties. 2 times 5 is 10. 10 pi inches, which is equal to 3.142 inches. The same rules apply for rounding here. Now we're going to talk a little bit about volume. Volume is the 3D measurement, so it's actual space. It's 3D space. Remember, the one-dimensional is just perimeter. That's just a line, how long. The two-dimensional is area, and that's like surface, like just 2D, like a piece of paper is just 2D. A flooring is just 2D, but a volume is 3D. So now it's into something we really understand. And here's some generic formulas for some pretty common volumes that we have to find. We know the volume of a cube is equal to s cubed, so it's pretty much just the area times the third dimension, which is the depth. Length times width times height. And for a cube, since all sides are equal, it's just s cubed. For a rectangle, it's just length times width times the height, or the depth that the object is. For a cylinder and a sphere, for a cylinder, all it is going to be pi r squared, which is the area of a circle, times the height. So pi r squared times the height. So again, it's just the area of a circle times the height that it's covering. For a sphere, which is a ball, it's going to be a little different. We're going to have a radius from the center of this globe and it goes directly out to the edge of the ball. The volume is going to be 4/3 pi r cubed. Okay, it's important to know that it's cubed, and it's 4/3 pi r cubed. So this one's a little tricky, okay? The next one we're going to do is a volume of a cone. This one's also a little tricky. It's 1/3 pi r squared times h, where h is going to be the height from the bottom all the way to the tip, and r is going to be the radius of the base. Okay. Here's an example. I'm going to go ahead and stop this video, and I'll finish the slides on the next video.